We're back. This is lesson H.16. Day 1, we're breaking this up into 2 days. And everything we've done so far has been with 2x2 matrices. Now things are going to get interesting because we're going to be doing 3x3 matrices. We're going to start by doing these with inverses, okay? So today is just all about finding the inverse of a 3x3 matrix. And you're going to love the mathematics today, okay? So here we go. We're going to start with this matrix. And it's example Laurel. It's x plus y plus z equals 2, 2x minus y plus z equals 5, and x plus 2y plus 3z equals 5. So you can see that what we want to do is write this as a matrix. And look at this. We've got a 3x3 matrix because we have 3 variables and 3 equations. So we've got this 3x3 coefficient matrix. There's our answer matrix, x, y, z, and our solution matrix, 2, 5, and 5. Okay, now, just like when we were doing 2x equals 6, and we multiplied by the inverse on both sides to solve it, we need to come up with the inverse, the thing that we're going to multiply this 3x3 matrix by, so that we get an identity. Because remember, 2 to the negative 1 times 2 times 2 to the negative 1 times 2 is 1. We need that identity. Such that we will end up with, so we're going to multiply both sides by a to the negative 1. Okay, there's a mistake here. This needs to be there because matrices are not commutative. So this needs to be in front of that matrix, and I didn't leave a space for it. So anyway, what we want to do is figure out what the inverse matrix is. Okay, well, what it is, it's equal to 1 over the determinant of A. See, this goes back to when we were doing 2x2s. Remember we had AD minus BC, 1 over AD minus BC. And I told you then that AD minus BC was the determinant. So we're back to that. And then what we've got is this mystery matrix, N. And if I multiply these two together, I'll get the inverse of the coefficient matrix. So you ready for some interesting mathematics here? Okay, step 1, finding the determinant of A. So what we're going to do is in green, we're going to write that coefficient matrix. It was 1, 1, 1, 2, negative 1, 1, and 1, 2, 3, okay? So we've got that. Now, this is kind of an odd thing, but what I'm going to do is I'm going to repeat these 2 first columns to the right. So I'm going to repeat 1, 1, 2, negative 1, and 1, 2. Okay, I've got those there. Do you remember all the diagonals we were doing earlier? Okay. Well, here's what we're going to do. I'm going to pull out, let's use yellow. So we have these diagonals. Can you see that okay? Barely, but I don't want them to get in the way. So we've got those diagonals, and we've got these diagonals. And we're going to multiply the numbers along those diagonals. Let's do the ones on top in red. So 1 times negative 1 times 1 is negative 1. 2 times 1 is 2. And 3 times 2 times 1 is 6. 1 times negative 1 times 3 is negative 3. 1 times 1 times 1 is 1. 1 times 2 is 4. Now we're going to take all the green numbers. Yeah, I have room to do it here. Okay. I've got the determinant of A. Where'd my pencil? Okay. So I've got the determinant of A equal to, I'm going to take all the blue numbers, the ones on the bottom, add them up, and subtract the numbers on top. -1 plus 2 plus 6. So this gives me 2 minus 7, which equals 5. So the determinant of A equals -5. Okay, we got that. Now, what we really need is what is 1 over that determinant. So 1 over the determinant of A equals 1 over, put the negative up on top, -1 over 5. Okay, so that was step 1, finding that determinant of A. Now, here's an interesting part. Okay, we got to find that matrix N, because the inverse of A is 1 over the determinant times this mystery matrix N. Okay, so we're going to go figure out what that is. This is some interesting mathematics right here. So I'm going to transfer over A equals 1, 1, 1, 2, -1, 1, and 1, 2, 3. All right. Now, this will be fun. N equals, it's a matrix. And yeah, I didn't mean to draw that long. It's a series of determinants. So I'm going to have a determinant here, a determinant here, and a determinant here. Repeat those. Okay, so there are 9 individual 2x2 determinants here. Right, hold on, I'm just getting stuff ready. Now, this first determinant is in the first row and first column. Okay, so what I'm going to do is I'm going to go up here, I'm going to cover up the first row, and I'm going to cover up the first column. Now that seems backwards, doesn't it? But what numbers do you see? -1, 1, 2, and 3. So the numbers here are -1, 1, 2, and 3. And then you go, okay, now this one is in the first row, second column. So I cover up the first row and the second column, and the numbers I see are 2, 1, 1, 3. 2, 1, 1, 3. This one, first row, third column, so I cover up like that, and I've got 2, -1, 1, 2. Okay, now I'm ready to do the second row, so I cover up the second row, first column, and the numbers I see are 1, 1, 2, 3. Slide it over, and I see 1, 1, 1, 3. Slide it over, 1, 1, 1, 2. Go to the third row, first column, and I see 1, 1, -1, 1. Then I see 1, oops, get a little over more, 1, 1, 2, 1. And finally 1, 1, 2, negative 1. So hopefully you see where all these numbers came from, okay? That leads to a little bit of arithmetic. So we've got negative 1 times 3 is negative 3 minus 2 times 1 is 2. We've got 2 times 3 is 6 minus 1 times 1 is 1. 2 times 2 is 4 minus 1 times negative 1 is negative 1. So we're going to make that a plus 1. Okay. Now we've got 1 times 3 is 3 minus 1 times 2 is 2. 1 times 3 is 3 minus 1 times 1, which is 1. 1 times 2 is 2 minus 1 times 1 is 1. 1 times 1 is 1 minus a negative 1, so that's plus 1. 1 minus 2 and negative 1 minus 2. Okay? We have some more arithmetic to do. You having fun yet? So this equals negative 5, 5, 5, 1, 2, 1, 2, negative 1, and negative 3. Okay, so far so good, because we're not even done. We're going to keep going. I'm going to repeat that matrix. Negative 5, 5, 5, 1, 2, 1, 2, negative 1, negative 3. I just repeated the same matrix because now I'm going to do some stuff to it. I'm just going to start here and I'm going to go plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay? Now, anything with a plus sign stays the same. Anything with a negative sign changes its sign. So now we have positive and negative 5 stays negative 5. Negative a positive 5, now that's negative 5. Positive 5 stays positive 5. Negative a 1 is negative 1. Then we've got positive 2. Negative the negative 1 is negative 1. We got positive 2 stays positive 2. Negative a negative becomes positive 1. And the negative 3 stays the way it is. Okay? And we're not done yet. Okay, so now what we're going to do is we're going to draw a diagonal across this thing, and we're going to flip this matrix across that diagonal. So anything on the diagonal stays where it is. These two switch places, these two switch places, and these two switch places. I'm not even making this up. That's exactly how you do that. So now we get this equal to the matrix. Okay, anything on the diagonal stays there, so let's put those in. And negative 3. I got a little blob of ink right there, but that's a positive 2. Then the 5 and the negative 5 and the negative 1 switch places. Negative 1, negative 5. The 2 and the 5 switch places. And the 1 and the negative 1 switch places. So we've got negative 5, negative 1, 2, negative 5, 2, 1, 5,